So we are working on converting between grams and moles, and here we have a scenario where we have um, 10 grams of carbon dioxide, and we want to know how many moles of carbon dioxide that is. All right? So what we're going to do is we're going to write an equal sign. What goes to the right of our equal sign, Fred?
The units you're after moles.
Good. Moles of carbon dioxide. And I'm starting with 10 grams. So I go 10 grams of carbon dioxide over here. And then what do I do?
Um, then you, molar mass of carbon dioxide.
That's right. I can go from grams of carbon dioxide to moles of carbon dioxide with the molar mass. And there's 44 grams per mole. We found, I mean, it tells us that up there. We could have also added it up on the periodic table, right?
Yeah.
Okay, good. So 0.2 moles of carbon dioxide, that's how many grams there are in carbon dioxide. Okay. All right, how about this one? What's the mass in grams of uh, 3.2 moles of calcium phosphate?
3.2 moles.
Yeah,
Okay. So that would be, we want grams, right?
very good. Do you want grams of calcium phosphate? And I need to start with 3.2 moles. And I'm going to go from moles of calcium phosphate to grams. Now, what's my conversion factor? How do I know how many grams there are per mole?
That's just the molar mass.
That's right. Just molar mass. Whoops, that's a 2. And I'm giving it here.
Oh, is that what that is?
Yeah, mm stands for molar mass there. So 310.18 should do the job. So 3.2 times the 310, that should be our 990. Okay, good. So another valuable tool is the ability to use the stoichiometry of chemicals, not equations, but chemical formulas to relate the number of moles of the different constituents in that chemical formula. So the term mole, for example, if I say I have 1 mole of sodium carbonate, 1 mole of sodium carbonate, I can say that in that I have 2 moles of sodium. Can you see that if I have 1 mole of this, I have 2 moles of sodium?
Yeah, I can see that.
Okay. Now that it bothers some people because they say, how can you get more moles of something from something that you don't have a lot of moles of? And the answer is um, this is kind of like a chocolate chip cookie or something, and I have some chocolate chips in it, 2 in each cookie. That doesn't mean that if I have 1 cookie that I only have 1 thing, right? I can have multiple chocolate chips in that cookie. And that's what this is like. It's saying I have 1 mole of this, and within that mole of that, there is 2 moles of sodium, 1 mole of carbon, and 3 moles of oxygen combined. Okay? Now the term mole is new to us, so if that bothers you, you can think of like dozen. If I have 1 dozen of this, I must have 2 dozens of these, and 3 dozens of those, and 1 dozen of those. Okay? Good. So, I can also say that, for example, I have 1 atom of carbon for every unit of sodium carbonate, 2 atoms of sodium for every unit of sodium carbonate. Okay? I can't say 1 mole of sodium for every unit of this. I'd have to say for every mole of this. But I can talk about how many atoms I have for every unit of a given compound. So how many moles of sodium are in 2.53 moles of sodium carbonate?
2.53 times 2.
Okay, good. That's the answer. But let's show why that's the case. I want to know moles of sodium, and I'm going to start with 2.53 moles of sodium carbonate. And I can go from moles of sodium carbonate and identify how many moles of sodium there are in each one. Each one of these sodium carbonates, Na2CO3, there's 2 moles of sodium. So 2.53 times 2 gives us the moles of sodium, because moles of sodium carbonate cancels out, and I'm left with my units of sodium. Okay? Now, if we wanted to calculate the number of atoms of sodium, what would we do differently?
Atoms of sodium would go to the right of the equal sign.
Good. Atoms of sodium will go to the right of the equal sign. I start with, again, moles of sodium carbonate. And I can go from moles of sodium carbonate to moles of sodium again. How many moles of sodium for every unit of this?
For every unit of sodium carbonate,
Yeah,
there's 2 moles of sodium.
right. 2 moles of sodium for every unit of sodium carbonate. And then I can go from moles of sodium to atoms of sodium.
How many is that? What's that difference?
Well, as you see, um, every mole of something has 6.02 times 10 to the 23rd atoms of it. Okay, that's Avogadro's number. And so 6.02 times 10 to the 23rd atoms of sodium are in every mole of sodium. So if I take 2.53 times 2 times 6.02 times 10 to the 23rd, that's going to give me my number of atoms of sodium. Make sure you can type that into your calculator and get that answer. Scientific notation can be difficult for some people sometimes. Okay, good.